Welcome back. You are now entering the Clay County Area Amateur Radio Club presents the 2020 to 2024 Extra Class Question Pool. My name is Michael, KC9, PHK. Today I'm presenting subelement E9 and E0, which will probably be some of the longest of the videos that we're releasing. 8 exam questions come from the 8 groups located inside subelement E9. First up, E9A, basic antenna parameters, radiation resistance, gain, beam width, efficiency, effective radiated power. E9A01, what is an isotropic antenna? A theoretical omnidirectional antenna used as a reference for antenna gain. E9A02, what is the effective radiated power relative to a dipole of a repeater station with 100 watts transmitter power output, 2 dB feed line loss, 2.2 dB duplexer loss, and 7 dBd antenna gain? That answer is D in this one, 286 watts. 286 watts. E9A03, what is the radiation resistance of an antenna? That answer is the value of the resistance that would dissipate the same amount of power as that radiated from an antenna. E9A04, which of the following factors affect the feed point impedance of an antenna? Antenna height. E9A05, what is included in the total resistance of an antenna system? Radiation resistance plus loss resistance. E9A06, what is the effective radiated power relative to a dipole of a repeater station with 200 watts transmitter power output, 4 dB feed line loss, 3.2 dB duplexer loss, 0.8 dB circulator loss, and 10 dBd antenna gain? 317 watts. E9A07, what is the effective isotropic radiated power of a repeater station with 200 watts transmitter power output, 2 dB feed line loss, 2.8 dB duplexer loss, 1.2 dB circulator loss, and 7 dBi antenna gain? 252 watts. E9A08, what is antenna bandwidth? That is the frequency range over which an antenna satisfies a performance requirement. E9A09, what is antenna efficiency? That is radiation resistance divided by total resistance. E9A10, which of the following improves the efficiency of a ground-mounted quarter-wave vertical antenna? Installing a radial system. E9A11, which of the following factors determines ground losses for ground-mounted vertical antenna operating in the 3 MHz to 30 MHz range? Soil conductivity. E9A12, how much gain does an antenna have compared to a half-wave length dipole when it has 6 dB gain over an isotropic antenna? 3.85 dB. E9A13, what term describes station output taking into account all gains and losses? That is effective radiated power. E9B covers antenna patterns and designs. E and H plane patterns, gain as a function of pattern and antenna modeling. E9B01, in the antenna radiation pattern shown in figure E9-1, what is the beam width? That answer is 50 degrees. E9B02, in the antenna radiation pattern shown in figure E9-1, what is the front to back ratio? That is 18 dB. E9B03, if the antenna radiation pattern shown in figure E9-1, what is the front to side ratio? That is 14 dB. E9B04, what is the front to back ratio of the radiation pattern shown in figure E9-2? 28 dB. E9B05, what is the term of antenna pattern shown in figure E-2? E9-2. And this is elevation. E9B06, what is the elevation angle of peak response in the antenna radiation pattern shown in figure E9-2? It is 7.5 degrees. E9B07, how does the total amount of radiation emitted by a directional gain antenna compare with the total amount of radiation emitted from a theoretical isotropic antenna, assuming each is driven by the same amount of power? They are all the same, is the answer. E9B08, what is the far field of an antenna? The region where the shape of the antenna pattern is independent of distance. E9B09, what type of computer-controlled technique is commonly used for modeling antennas? That answer is method of moments. E9B10, what is the principle of method of moments analysis? A wire is modeled as a series of segments, each having a uniform value of current. E9B11, what is a disadvantage of decreasing the number of wire segments in an antenna model below 10 segments per half wavelength? The computed feed point impedance may be incorrect. E9C covers practical wire antennas, folded dipoles, phased arrays, effects of ground near antennas. E9C01, what is the radiation pattern of two quarter wavelength vertical antennas spaced half wavelength apart and fed 180 degrees out of phase? A figure 8 oriented along the axis of the array. E9C02, what is the radiation pattern of two quarter wavelength vertical antennas spaced quarter wavelength apart and fed 90 degrees out of phase? Cardioid. E9C03, what is the radiation pattern of two quarter wavelength vertical antennas spaced half wavelength apart and fed in phase? A figure 8 broadside to the axis of the array. E9C04, what happens to the radiation pattern of an unterminated long wire antenna as the wire length is increased? The lobes align more in the direction of the wire. E9C05, which of the following is a type of OCFD antenna? A dipole fed approximately 1/3 of the way from one end of the 4-to-1 balun to provide a multi-band operation. E9C06, what is the effect of adding a terminating resistor to a rhombic antenna? It changes the radiation pattern from bidirectional to unidirectional. E9C07, what is the approximate feed point impedance at the center of a two-wire folded dipole antenna? 300 ohms. E9C08, what is a folded dipole antenna? A half-wave dipole with an additional parallel wire connecting its two ends. E9C09, which of the following describes a G5 RV antenna? That is a multiband dipole antenna fed with coax and a balun through a selected length of open wire transmission line. E9C10, which of the following describes a ZEP antenna? An end-fed dipole antenna. E9C11, how is the far field elevation pattern of a vertically polarized antenna affected by being mounted over seawater versus soil? The low angle radiation increases. E9C12, which of the following describes an extended double ZEP antenna? And that is a center-fed 1.25 wavelength antenna, or two 5/8 wave elements in phase. E9C13, how does the radiation pattern of a horizontally polarized 3-element beam antenna vary with increasing height above ground? That is, the takeoff angle of the lowest elevation lobe decreases. E9C14, how does the performance of a horizontally polarized antenna mounted on the side of a hill compare to the same antenna mounted on flat ground? The main lobe takeoff angle decreases in the downhill direction. E9D, Yagi antennas, parabolic reflectors, circular polarization, loading coils, top loading, feed point impedance of electrically short antennas, antenna Q, and RF grounding. E9D01, how much does the gain of an ideal parabolic dish antenna change when the operating frequency is doubled? That is 6 dB. E9D02, how can linearly polarized Yagi antennas be used to produce circular polarization? That is, arrange two Yagis perpendicular to each other with the driven elements at the same point on the boom fed 90 degrees out of phase. E9D03, where should a high Q loading coil be placed to minimize losses in a shortened vertical antenna? Near the center of the vertical radiator. E9D04, why should an HF mobile antenna loading coil have a high ratio of reactance to resistance? To minimize losses. E9D05, what usually occurs if a Yagi antenna is designed solely for maximum forward gain? The front to back ratio decreases. E9D06, what happens to the SWR bandwidth when one or more loading coils are used to resonate an electrically short antenna? It is decreased. E9D07, what is the advantage of using top loading in a shortened HF vertical antenna? Improved radiation efficiency. E9D08, what happens as the Q of an antenna increases? SWR bandwidth decreases. E9D09, what is the function of a loading coil used as part of an HF mobile antenna? To cancel capacitive reactance. E9D10, what happens to feed point impedance at the base of a fixed length HF mobile antenna when operated below its resonant frequency? The radiation resistance decreases and the capacitive reactance increases. E9D11, which of the following conductors would be best for minimizing losses in a station's RF ground system? That is, wide, flat copper strap. E9D12, which of the following would provide the best RF ground for your station? That's an electrically short connection to three or four interconnected ground rods driven into the earth. E9E, matching antennas to feed lines, phasing lines, and power dividers. E9E01, what system matches a higher impedance transmission line to a lower impedance antenna by connecting the line to the driven element in two places spaced from a fraction of a wavelength each side of the element center? The delta matching system. E9E02, what is the name of the antenna matching system that matches an unbalanced feed line to an antenna by feeding the driven element both at the center of the element and at a fraction of a wavelength to one side of center? The gamma match. E9E03, what is the name of the matching system that uses a section of transmission line connected in parallel with the feed line at or near the feed point? That is the stub match. E9E04, what is the purpose of a series capacitor in a gamma type antenna matching network? To cancel the inductive reactance of the matching network. E9E05, how must an antenna's driven element be tuned to use a hairpin matching system? The driven element reactance must be capacitive. E9E06, which of these feed line impedances would be suitable for constructing a quarter wave Q section for matching a 100 ohm loop to a 50 ohm feed line? That is 75 ohms. E9E07, what parameter describes the interactions at the load end of a mismatched transmission line? Reflection coefficient. E9E08, what is the use of a Wilkinson divider? That is, it is used to divide power equally between two 50 ohm loads while maintaining 50 ohm input impedance. E9E09, which of the following is used to shunt feed a grounded tower at its base? A gamma match. E9E10, which of these choices is an effective way to match an antenna with a 100 ohm feed point impedance to a 50 ohm coaxial cable feed line? Insert a quarter wave piece of 75 ohm coaxial cable transmission line in series between the antenna terminals and the 50 ohm feed cable. E9E11, what is the primary purpose of phasing lines when used in an antenna having multiple driven elements? That answer is, it ensures that each driven element operates in concert with the others to create the desired antenna pattern. E9F covers transmission lines, characteristics of open and shortened feed lines, coax versus open wire, velocity factor, electrical length coaxial cable dielectrics. E9F01, what is the velocity factor of a transmission line? The velocity of the wave in the transmission line divided by the velocity of light in a vacuum. E9F02, which of the following has the biggest effect on the velocity factor of a transmission line? That is, dielectric materials used in the line. E9F03, why is the physical length of a coaxial cable transmission line shorter than its electrical length? Electrical signals move more slowly in coaxial cable than in air. E9F09, what impedance does a half-wave length transmission line present to a generator when the line is shorted at the far end? Very low impedance. E9F05, what is the approximate physical length of a solid polyethylene dielectric coaxial transmission line that is electrically quarter wave length long at 14.1 megahertz? 3.5 meters. E9F06, what is the approximate physical length of an air-insulated parallel conductor transmission line that is electrically half wavelength long at 14.10 megahertz? 10.6 meters. E9F07, how does ladder line compare to small diameter coaxial cables such as RG58 at 50 megahertz? Lower losses. E9F08, which of the following is a significant difference between foam dielectric coaxial cable and solid dielectric cable, assuming all other parameters are the same? All of these choices are correct. So foam dielectric has lower safe operating voltage limits, foam dielectric has lower loss per unit of length, and foam dielectric has higher velocity factor. E9F09, what is the approximate physical length of a foam polyethylene dielectric coaxial transmission line that is electrically quarter wavelength long at 7.2 megahertz? 8.3 meters. E9F10, what impedance does a eighth wavelength transmission line present to a generator when the line is shorted at the far end? An inductive reactance. E9F11, what impedance does a eighth wavelength transmission line present to a generator when the line is open at the far end? That is a capacitive reactance. E9F12, what impedance does a quarter wavelength transmission line present to a generator when the line is open at the far end? Very low impedance. E9F13, what impedance does a quarter wavelength transmission line present to a generator when the line is shorted at the far end? Very high impedance. E9G, the Smith chart. E9G01, which of the following can be calculated using a Smith chart? Impedance along transmission lines. E9G02, what type of coordinate system is used in a Smith chart? Resistance circles and reactance arcs. E9G03, which of the following is often determined using a Smith chart? Impedance and SWR values in transmission lines. E9G04, what are the two families of circles and arcs that make up a Smith chart? Resistance and reactance. E9G05, which of the following is common use of a Smith chart? Determine the length and position of an impedance matching stub. E9G06, on the Smith chart shown in figure E9-3, what is the name for the large outer circle on which the reactance arcs terminate? That's the reactance axis. E9G07, on the Smith chart shown in figure E9-3, what is the only straight line shown? That's the resistance axis. E9G08, what is the process of normalization with regard to a Smith chart? Reassigning impedance values with regard to the prime center. E9G09, what third family of circles is often added to a Smith chart during the process of solving problems? Coaxial length circles. E9G10, what do the arcs on the Smith chart represent? Points with constant reactance. E9G11, how are the wavelength scales of a Smith chart calibrated? In fractions of transmission line electrical wavelength. E9H covers receiving antennas, radio direction finding antennas, beverage antennas, specialized receiving antennas, and long wire receiving antennas. E9H01, when constructing a beverage antenna, which of the following factors should be included in the design to achieve good performance at the desired frequency? It should be one or more wavelengths long. E9H02, which is generally true for low band, meaning 160 meter and 80 meter receiving antennas. Atmospheric noise is so high that gain over a dipole is not important. E9H03, what is receiving directivity factor, RDF? And that's forward gain compared to average gain over the entire hemisphere. E9H04, what is the advantage of placing a grounded electrostatic shield around a small loop direction finding antenna? It eliminates unbalanced capacitive coupling to the surroundings, improving the nulls. E9H05, what is the main drawback of a small wire loop antenna for direction finding? It has a bidirectional pattern. E9H06, what is the triangulation method of direction finding? Antenna headings from several different receiving locations are used to locate the signal source. E9H07, what is RF attenuation? Why is RF attenuation used when direction finding? To prevent receiver overload, which reduces pattern nulls. E9H08, what is the function of a sense antenna? It modifies the pattern of a DF antenna array to provide a null in one direction. E9H09, what is a pennant antenna? A small vertically oriented receiving antenna consisting of a triangular loop terminated in approximately 900 ohms. E9H10, how can the output voltage of a multi-turn receiving antenna be increased? By increasing the number of turns and or the area. E9H11, what feature of a cardioid antenna, pattern antenna, makes it useful for direction finding? A very sharp single null. Subelement E0 covers safety. One exam question comes from the one group here. E0A covers safety, RF radiation hazards, hazardous materials, and grounding. E0A01, what is the primary function of an external earth connection or ground rod? And that is lightning protection. E0A02, when evaluating RF exposure levels from your station at a neighbor's home, what must you do? Ensure signals from your station are less than the uncontrolled maximum permitted exposure limits. E0A03, over what range of frequencies are the FCC human body RF exposure limits most restrictive? That is 30 to 300 megahertz. E0A04, when evaluating a site with multiple transmitters operating at the same time, the operators and licensees of which transmitters are responsible for mitigating overexposure situations. Each transmitter that produces 5% or more of its MPE limit in areas where the total MPE limit is exceeded. E0A06, why are there separate electric and magnetic field MPE limits? The body reacts to electromagnetic radiation from both the E and H fields. Ground reflections and scattering make the field strength vary with location, and E field and H field radiation intensity peaks can occur at different locations. All of these choices are correct. E0A07, how may dangerous levels of carbon monoxide from an emergency generator be detected? Only with a carbon monoxide detector. E0A08, what does SAR measure? The rate at which RF energy is absorbed by the body. E0A09, which insulating material commonly used as a thermal conductor for some types of electronic devices is extremely toxic if broken or crushed and the particles are accidentally inhaled? That's beryllium oxide. E0A10, what toxic material may be present in some electronic components such as high voltage capacitors and transformers? Polychlorinated biphenyls. E0A11, which of the following injuries can result from using high power UHF or microwave transmitters? That is localized heating of the body from RF exposure in excess of MPE limits. And that will conclude this video series. Thank you for following along. Hopefully you enjoy these videos and that they will benefit you in obtaining your amateur extra class license.